So my name's Carlos Nunez. I work for a consulting group called Contino out of New York, Atlanta, and London. I came to DevOps Days Nashville because I spoke at DevOps Days Dallas just a few months prior, and I had a blast. I loved talking there, and I loved all the people that I met. So when I got the invitation to talk here, I super excited. I needed a reason to come to Nashville and actually explore it. So here I am. I had a great time. Everyone here was fantastic. The talks were amazing. The other vendors that I met were great. Everyone was lovely. And I've been with Contino for about 6 months. And one of the things that I like, or one of the best things that I like about working with them is that we take the time to actually work with other engineers on projects. I've been with other consulting groups and other companies who like to just get something to work on and then bring their own engineers to work on it in kind of a corner. And we don't do that. We actually care about helping others learn more because I think we learn better when we work together, and we actually do that in practice, and it's amazing what you can do when you actually pair.
Hey everybody, how are y'all doing? I can literally feel the excitement from that response right up here. It's like get into me. Let's try that one more again. How are y'all doing? Nice. Woo! There we go. All right. So now you can see I'm using speaker notes. Fantastic. I promise I did practice this. All right. So for those of you that don't know me, my name is Carlos Nunez. I too work for Contino. I too used to work at ThoughtWorks. The timing couldn't have been any better. So Adarsh did a great job explaining who we are and what we do. So I'm not going to reiterate over that again, but I will say that after this talk, I will post these slides on Twitter. And if you want to follow me on Twitter, I have the easiest name ever because my handle is literally easiest name ever. You can also email me at carlos@contino. So before I start my talk, I'd like to ask y'all a question. How many of you here use configuration management tools? Chef, Puppet, Ansible, Salt, CF Engine. Fantastic. Great hands. How many of you used that same infrastructure to provision infrastructure, say servers, load balancers, networking appliances, you name it? How many of y'all have used those tools to do that? One hand. Two hands, sorry. Let me not forget the two or three. Oh, we have three. All right, out of y'all three, how many of you actually enjoyed that experience? 0 hands. Amazing, I agree with you. Why? Because configuration management is not provisioning. Why? Well, before I start my talk again, let me start with a little story of why I'm here, basically. So I was a systems administrator at a popular startup in New York, and they wanted me to deploy an Active Directory forest with 1 or 2 domains from scratch, right? And they wanted me to do it automatically. So I'm thinking, okay, great. We're going to use Ansible to do the whole thing. We're going to use Ansible to provision the servers, to provision the Active Directory forest and the domain, and we're going to do it all with Ansible. And it was great for like the first week. For the first week, it was fantastic. Then I needed to associate security groups with those instances. And that's where stuff started getting really complicated because, as I'll explain, creating security groups is easy with Ansible. Creating them and associating them with stuff is a little bit more difficult. And then it got even more difficult after I wanted to add new instances into that playbook, right? I need to create a password reset server, and I need to add it to the playbook. That got really complicated. Adding tags, really complicated. I'll save you all the rest of the story. Long story short, it took me a month to build this thing. And I'm talking nights and weekends here. It took me a month to build this thing, right? The day after I said, I finished it, this thing works, it's fantastic, my boss comes up to me and says, we're switching to Amazon Enterprise Active Directory. Sorry, Carlos, we don't need your work. So that's why I gave this talk in Dallas, and that's why I'm giving it here, because I'm hoping to avoid y'all from that pain. So what is provisioning, right? What do I mean when I say provisioning? It's kind of a generic term. So let me go ahead and define that for y'all. Provisioning, in my mind, is the ability to create, modify, and or delete infrastructure using code or APIs. Now, I want to focus on the code or APIs bit for a second, because I think this is very important. When we talk about DevOps and we talk about the DevOps culture, one of the things that we like to focus on is not throwing things over the wall, not siloing things, as Adarsh did a really good job explaining, right? With code, that enables the breakdown of silos, because now you have a common language throughout which you can talk to other teams, you can talk to the business, and show the business this is what your business is powered by, and this is how it runs, right? So, in the old world, now, and when I say old world, I mean when I was a Windows systems administrator years and years ago, back in my day, we would get the hardware, we would procure it, rack it, and stack it. In today's world, that could be provisioning an instance on AWS or Google Cloud, or spinning up a VM with VMware. We would have to get the hardware, right? But after we got the hardware is where things got a little bit tricky, right? We need to consult a run book and say, how do we actually kickstart this thing? So we consult the kickstarting run book, and then we maybe run some installation scripts that might be part of that run book, or may be institutional knowledge from that one guy or lady that worked there for like 15 years. And then after that, if we have a configuration management tool like Chef or Puppet, then we wait for it to do its thing. If we don't, then there's just more sadness, more scripts, more clicking, more pain, right? In the new world, which I'm gonna call here the new world, you get your hardware, same thing, or get your infrastructure, you get your primitives, so your infrastructure, and then you just run Terraform plan. Or if you're gonna use CloudFormation, you run AWS CF, update your stack, right? And then you do Terraform apply, you deploy the stack, because this is all infrastructure as code at this point, and then you become this amazing little cat whose picture is way too small, as I just realized. But you chill, right? You chill, because it's all automated, it's all infrastructure as code, it's beautiful, right? So why provisioning, why infrastructure as code? Well, I have 3 reasons for this. The first reason is that there's no more runbooks. Old world, there were runbooks, there were docx runbooks. You hope to God they were updated. In this world, it's all in code, in Git or in Bitbucket, in your SCM, right? And I want to take a second here and ask y'all to read this snippet of code. This worked better in Dallas, I'm realizing. The screen was a little easier to read, but hopefully, I hope you guys can see this. How many of you understand what's going on here in a gist? All right, maybe the screen's a little too small. But the point that I was trying to get at here is that if you do look at this code, and again, I'm going to distribute the slides again tomorrow, you can see that it is very straightforward. It's very easy to read. You can go to anybody in the organization and show them this, and the likelihood of them understanding what's going on is much, much greater than if you just had a bunch of scripts, right? And because of that, you get to save time, right? Because you don't have to write thousands of lines of code to provision infrastructure with some existing tools that weren't exactly meant to do that. It's all automated and all accounted for you. And because of this, you get to treat your infrastructure like software, right? And the benefit of this is that software is testable. You can test software and ensure that your software does what you want. And now you can do that with your infrastructure much easier. You can enable unit tests. You can enable integration tests. You can enable regression tests if you want. You can really, really make your infrastructure bulletproof. And you can avoid it from being fragile infrastructure that breaks all the time, right? And as an example of that, we're going to go to this Terraform configuration and just show you a snippet of what Terraform looks like. So with this configuration, we're deploying a web server. And with this web server, we want to use a particular AMI because we're on Amazon in this instance. We want a certain number of these servers to be created. Maybe it has a name, maybe it has subnets, a particular subnet you need it to be in, etc. It provisions a web server, right? Now, the magic in this is, what if I want to deploy this 1,000 times, right? I just want 1,000 of these. The magic is, I go into that directory, I do Terraform plan, because with Terraform you can plan your configuration before you apply it, as well as with CloudFormation. I say, I want to plan this with 1,000 instances, right? So I'm going to put number of instances, 1,000, right? It shows my plan, it looks good, and then I apply it, and boom, in about, it depends on how long it takes to provision, but in a short number of time, you have 1,000 web servers with 2 commands. 2. Easy, right? So now let's talk about what I mean by configuration management, because this is another term that's been it's been used in a lot of different contexts. So what I mean by configuration management is that it expresses the state of your infrastructure with code and APIs. And I want to hone in on state a little bit. What I mean by state is not the relationships within that infrastructure. I'm talking about what that infrastructure does. So if I use Chef to provision a web server, that Chef cookbook is going to tell me what that web server looks like and what is in that web server and what it's used for, right? That's what I mean by configuration management in this case. And again, there are 3 advantages to using configuration management. And before I continue, I actually asked this earlier, so I won't ask it again. But the 3 advantages to using this. The first advantage is that you get consistent and repeatable infrastructure this way, right? Because with something like Chef or Puppet, you can ensure that all of your web servers look the same and act as you'd like them to. Similarly to our provisioning tools, you get a simple domain-specific language that you can use to express what these look like. And again, you get to present these to anybody in the organization. You can say, with my provisioning tools, this is how my infrastructure gets deployed. With configuration management tools, this is what they do. And you can show them exactly what they do. And because configuration management tools usually have APIs and usually are built on top of a mature language, you can extend it as much as you want, right? So in Chef and Puppet's case, you can write Ruby code to do anything that you need it to do if it's too limiting. And same thing with Ansible and Salt. For those that use Salt, it uses Python, so you get the same advantage there. Now, I'll just go with a brief example for those that don't have experience with these tools. This is an example of Ansible. Ansible is a configuration management tool that uses YAML. So in this example, I'm installing an application called Tree. How many of you are familiar with this? Tree? Cool. So it's really convenient. It shows you your directory listing in a convenient tree. I use this all the time. It's super convenient. So yay, Tree, I installed it with Ansible, right? And then I can use an inventory file or specify my host here to say which host I want Tree installed on. And in this case, I want to install it on some useless server in Virginia. So I'm going to install it on there, and then I run Ansible playbook 4 of these with my inventory file and some other flags if you want. And then after a few minutes, you get Tree. Yay, Tree. Tree is amazing, right? So based on my explanation earlier, you might be saying, man, Ansible, Chef, I can do anything with it, right? Like I can extend it as much as I want because it's just Python or it's just Ruby, right? I can do whatever I want. I'm going to provision all of my infrastructure with it because Chef has Chef provisioning, Ansible has provisioning modules. I'm going to do it. Yeah, no, I don't really think you should though, right? Let's not do that. What do you mean, Carlos? Why can't I do that? Ansible is just Python, Chef is Ruby. I mean, I don't understand, right? So the point that I want to drive here is that it's all about state. And I'm going to use 3 examples of that. The first example of that is that there is a cost to idempotency. And I hate this word, by the way. Like, there's 2 ways to say it. There's idempotency and idempotency. And both of them are awkward. So we're just going to go to idempotency, right? So what does this word mean, right? According to, I think this was dictionary.com, Wikipedia, pardon me. So Wikipedia defines idempotency as a mathematical property whereby certain operations can be applied multiple times without changing the result beyond the initial application. So when I run my Chef cookbook, when I'm on my Ansible playbook, it's just going to do it multiple times. It's going to steamroll over whatever's already there because it's idempotent, and at the end, you're going to get whatever it is that you say is going to be there with your Chef Cookbook or Ansible playbook, right? And this is great for configuration management. This is great for laying down what your applications look like because you want them to be consistent. You want them to be uniform. But the problem with infrastructure is that relationships exist between them. As with my story earlier, for example, I have security groups that are related to the instances that I created in this Active Directory for us. In other examples, you might have load balancers, you might have tags that are shared across multiple pieces of infrastructure. There's relationships that are there that you can't just steamroll. And in order to account for them, you have to calculate them, and that can be difficult. So let's go with an example of what I mean. So going back to my web server example, I'm going to use Ansible to provision a web server, and I'm going to use the EC2 module to do that. So as you can see up there, you can see that you have all of your parameters, your AMI, the number of instances you want. It looks very similar to our Terraform configuration code that I showed earlier, right? But I want to hone in on just one thing, and that one thing is the exact count, right? So in my earlier example, I provisioned 1,000 of these. Now, with Ansible, it can provision 1,000, or the Ansible EC2 module, it can provision 1,000 instances, no problem, right? But the question is, how do we guarantee that it's 1,000 instances that we want? How do we guarantee that Ansible isn't just going to look at AWS and say, there's 1,000 there, but I'm Ansible and I'd steamroll, so I'm just going to deploy 1,000 again. Or that there's 998, I'm going to deploy 1,000 on top of that 998 that already exists. Like, how do you guarantee that you get the exact count that is specifying here, right? The answer to that is that you need to gather that state externally. What do I mean by gathering state externally? How many of you used AWS's CLI tool, the Python tool, right? Cool. So I might use that, and I do in this case, to check how many servers are already, how many web servers are already there that I want to account for in my 1,000. And then I use that information to say, okay, thank you AWS CLI for getting this information for me. Now Ansible deploy this many, right? And that sounds fair. That sounds fair. That solves our one problem. So I guess we're good, right? Not really, because there's other edge cases that you need to consider, right? Like, what if you're running this on some automated server and AWS CLI isn't there? What do you do in that case? Or what do you do if you're running this in a pipeline and the access key that you're using for your AWS CLI is invalid or it was invalidated by security team and you get some garbled output? What do you do in that case? Or what do you do if your pipeline server is on some latent network, or you're doing this on a boat in development, and your network latency is super high, therefore this is super slow, and it times out all the time? What do you do in these situations? Well, you can account for all these things in a module. You can say, all right, I'm going to build a module, and this module is going to account for every one of these things. It's going to solve for network latency. It's going to solve for edge cases. It's going to solve for everything. It's going to solve for everything, right? But what about other edge cases? Like, what if I want to, going back to my previous example, what if I want to create security groups dynamically, right? Or what if I want to create other resources dynamically relative to this? Well, you create more modules, right? Like, what's the problem with that? Well, I hope that my point is clear. You're going back to this. You're going back to your old world, right? You're writing scripts again. But except this time, you're doing it with Ansible, and you're doing it with some simple domain-specific language that at this point is going to get really complicated because now you're stretching it. And now you have a bunch of code that people don't understand, that your business no longer understands. And now you're having teams throwing over the wall, you're having hero complex, you're having a bunch of things that are not part of our DevOps culture, right? So you lose the simplicity. And at Dallas, I heard Adam Jacobs talk, and if you haven't heard Adam Jacobs talk, it's a real treat. Y'all should. He's a great speaker. And he made a reference to this thing called the peak of false hope, right? Where you pick up a new tool and you're using this tool and it's great. It does everything you want. It is so dope, and you show it to everybody on your team and they start using it, and they use it. The hype intensifies, and then it gets to a point where it just becomes really complicated, right? And now you have to really make this thing work in production or in a higher environment, and then it just starts downsloping to sadness, right? So sadness lies ahead of that curve. But with tools like Terraform or CloudFormation, that's no longer the case, because with tools like Terraform or CloudFormation, it keeps track of your state. So all those calculations you were making before are accounted for you. And because they're accounted for you, you can spend more time writing bulletproof infrastructure and less time fighting fragile infrastructure. And now you're climbing that path to success, right? It's no longer an uphill battle at that point. So the next thing that I wanted to hone in on a little bit is that keeping track of your state is up to you, which I kind of showed in my previous example, but I want to just use one more example in this case to show y'all what I mean. So let's take a look at this example. On the bottom, I'm adding some tags. And as many of you are probably familiar, cost center is extremely important, because how are we going to pay for all this? Right, so I want to add a tag that tells me which cost center these instances belong to. So I have my Ansible playbook, I provide the change in an environment variable, and I want to ask y'all a question that was already answered. Fantastic. What happens if this changes? I gave y'all the answer, and you all agree with me. Nothing happens. Nothing happens when you run this. Because, again, Ansible doesn't keep track of this, you do. So if you want something to happen, you have to calculate it, right? And with provisioning tools, that's already accounted for in your state. So when you do change a tag, Terraform or CloudFormation know that that tag was changed. And once that tag is changed and you do the Terraform apply or you do the CloudFormation deploy, then it's changed for you without you having to do additional work, right? The third thing I wanted to focus on is rollbacks. What happens when something fails, right? So just one more example for y'all. So going back to our web server, so I'm running this in the middle of a deployment. What happens if this fails? Anyone want to take a gander at this? Thank y'all, great job. Nothing happens, right? Because when it fails, Ansible doesn't know what happened before. Or if it does, it's probably because, again, you added some sort of plays, you added some sort of code that keeps track of what happens before. So the rollback is on you. And now I should elaborate. In the case of Terraform, it explicitly tells you when you do a run and it fails, that rollback, it doesn't roll back in the event of a failure, right? But the key to note, though, is that it knows where it failed and it knows where to pick up. And in order to do this with a tool like Ansible Chef, you have to make it such that it does that. And that can be challenging. And I want to be clear. I'm not trying to say that this is impossible, okay? You can write all this stuff in Ansible Chef, Puppet, whatever configuration management tool you want, except CF Engine. I don't know if you can do it in there. But you can write this stuff. What I'm trying to say, though, is that your time is better spent on making your infrastructure better and more resilient, making your infrastructure go to the next level so you can take your business to the next level. And provisioning tools like this let you do that without spending time fighting fires. So with that, let's segue into some tools that are available. And I highlighted two of them already, but let me elaborate on why I recommend them. So the tool I recommend in most cases is Terraform. And I promise I'm trying not to be biased, despite me wearing a HashiCorp shirt. But I promise I'm not biased. There's a reason why I recommend it. The biggest reason is that it is cross-cloud, cross-vendor, cross-platform. It works on anything. It's portable. So if you want to use this on AWS or Google Cloud or Azure or even on VMware, on vSphere or OpenStack, you can do that because Terraform has a concept of providers. And providers are the glue between Terraform and your infrastructure. So you can even write your own providers. I think when I was doing research on this, I found a provider for, I want to say, Juniper network devices. Don't quote me on that. I think it exists. I'm not sure. But I did see a provider for networking appliances, and I thought that was really cool. So providers let you do a lot and really go far with what you can do with infrastructure as code. But CloudFormation is a great tool if you're on the AWS stack. Why? Because it's native to AWS. It's a first-class concept. So you can use this to, yeah. Oh, 5, okay. So yeah, you can use this with knowing that if you're on an AWS stack and you want to try something new, like recognition or Snowflake or something like that, you know that it will be supported. Or if it's not supported, it will be supported soon. How many of you all know an OpenStack? How many of you are running OpenStack? How many of you are on OpenStack projects? Wow, that is not the answer I expected, but cool. Anyway, for those of you that are considering OpenStack or have, there's a tool called Heat that does this. It's very similar. It's very similar to Terraform in that you get a domain-specific language. It's very easy to use, very easy to learn. It's specific to OpenStack, so it supports all of OpenStack's providers and all of OpenStack's services. So there's another tool to consider. So I guess the question, and I kind of answered this, actually it did not, but I want to make this clear. For those of you that are asking, are you telling me, Carlos, that I can't use Chef anymore? Should I just use Terraform all of a sudden? Can they not work together? I want to be very clear. They can absolutely work together. In fact, with Terraform, it has the first-class concept of using a configuration management tool after you provision your infrastructure so that when you provision your web server, you can then run Chef and let Chef or Puppet do its job, right, and do what it's good at. So I actually, for our clients and before I even joined Contino, I've always recommended that pattern where in your pipeline you're using Terraform to provision your infrastructure and then you're using Chef and Puppet or whatever configuration management tool you're using to actually lay down what that infrastructure is going to do. So, in closing, I just want to summarize what I talked about up here. So, configuration management is not provisioning. They're not the same thing. Those tools are two distinct tools that are two different tool sets that are good at two different things. Configuration management expresses what your infrastructure is going to do, where provisioning actually lays down that infrastructure, at least how I define it. It's also all about state, and that's the reason why they're different in this case. With configuration management, if you were to use those tools to provision your infrastructure, you have to calculate that state yourself, and that gets challenging, whereas provisioning tools take care of that for you automatically, and provisioning tools make your life easy. CloudFormation, Terraform, Heat. There's also Cumulus. Has anyone played around with that one? Cumulus? No? Yeah, well, it's kind of a minor tool. It's a little bleeding edge, I think. But these tools make your life easy, so use them. It just makes your life easier. And with that, thank you guys for having me and letting me talk for a few minutes.